Okay, today I'm going to explain lab activity 1, lab activity 2. I'm going to explain. Now, you will see uh, okay. Now, I'm going to explain lab activity 1. Lab activity 1. Colors, silent, color. Blue, at least blue. Activity 1. Lab activity. Lab activity 1. Lab activity 1. Now, in this lab activity, I'm going to explain. What is our aim is just so relation between, do you know one thing? Light travels from, this is a light travels from radar medium to denser. Radar medium to denser. Radar medium to denser. Now, this is you will take, this is a radar medium, this is a denser. Radar medium, denser. This is a light travels from, this is a beam of light. This is we call normal line. This is this line indicates interface. Interface can divide into two mediums. Interface divided into two mediums. This is a beam of light. Beam of light is traveling towards another medium. This is a beam of light is traveling towards a beam of another medium. This is we call incident ray. This is a normal ray. Angle between incident and normal we call angle of incident. Angle of incident. Angle of incident. Now this is the actual direction of incident. This is the actual direction of incident. This is the actual direction of incident. Actual direction of incident. Actual direction of incident. Now this is travel from radar medium to denser medium means this is a refractory bends towards a normal. Towards a normal. This is refractory. This is the angle of R. Angle of R. This is the angle of I. Now this is, I'm going to explain. Our aim is relation between and I, angle of I, angle of R. So lab activity. Our aim is so we are showing relation between angle of I, angle of R, angle of I, angle of R. But light should travel from radar medium to denser medium. Refractory bends towards a normal. That I'm going to explain. In this lab activity, I'm going to explain light travels from radar medium to denser medium. Refractory bend towards a normal. I am showing that one. Now you will see in this case, suppose for example, I'm taking in this lab activity, what I'm going to do, you see clear. Now, so our aim is, you see, sin I by sin I angle of I sin of angle of R is equal to constant. That I'm going to show that this is constant. Our aim is relation between angle of I, angle of R, and sin A by sin R is equal to constant. I am showing. Now you will see in this situation what I'm doing here. In this situation, in this situation. So now material. So next I want to material. So I want to what we call components. We call requirement. Okay. So next I want to, okay, I'm taking, this is we call cardboard sheet. You fill cardboard sheet. I'm taking the white paper. White paper covers, white paper keeps on the cardboard sheet. Cardboard sheet. Next, I'm drawing the line. This is a line. This is a line. This is a horizontal line. This is a vertical line. This is a central point. Central point. Now I'm taking protector. The protector. This is 0 degrees. Here also 0 degrees. 0 degrees. Now this is a reading. I am showing the reading. Protector is placing on like this. This is a protector. So this is a protector. This is made up of. This is a protector. This is made up of glass. This is made up of glass. Generally, so mu g is equal. Value is 3 by 2. 3 by 2 means that is 1.5 value. Refractive index of the glass. Refractive index of the glass is 3 by 2 or 1.5. 1.5, that is a practical value. Practical value. Okay, now this is glass. Now you will see what will happen in this situation. In this situation, well, I'm drawing. This is made up of glass. The protector is made up of glass. So O point also. Yes, this is fine. Now this is a line number one, and this is I'm taking 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a 10th line. This is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th line. 10th line. Now we will see this is a lines. Zero degrees, 10 degrees, 20 degrees, 30 degrees, 40 degrees, 50, 60, 70, 80, 90. This is a 90 degrees and 90 degrees. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a line. You take 70, 80. This is a 90 degrees. 90 degrees in the midpoint. This is a one point there. That is a point. This point indicates, small point indicates. This is a 5 degrees. 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90. Like this. That's glass. Now this side is this side. This is we call denser medium. Denser medium. This is a line we call this is interface. We call this is a interface line. This is we call interface. Interface line. This interface line divides the two mediums. This is a denser medium. This is a rarer. Here, air is occupied. Interface line. This is a interface line. Interface. Now this is a air in this occupied air. This is we call rarer medium. Rarer medium. Rarer medium. Rarer. This part is rarer medium. This is a denser medium. Denser medium. Denser medium. What I'm going to show in this activity, relation between angle of I, angle of R. Relation between angle of I, angle of R, and sin I by sin R is equal to constant. I'm showing. Now this is a denser medium. This is a rarer. Now you will see what will happen in this situation. Now we'll see first line, second, third, fourth, fifth, sixth, seventh, eighth, 9, 10. 10 degrees, 20 degrees, 30 degrees, 40, 50, 60, 70, 80, 90 degrees. 90 degrees. This is a lines. 10. This is a 20, 30, 40, 50, 60, 70, 80, 90. This is angles. This is angles also 5 degrees. This 5, 15, 20, and this is we taking small angles. I'm taking like this. I'm taking like this. Now you will see. We know very well. This is glass means. Now you will see. This is a glass. This is a denser medium. Glass means glass is taken as denser medium. This is air in this part. Air. Air means it's take rarer medium. Rarer medium. Now light travels from light travels from rarer medium to denser medium. Light travels from rarer medium to denser medium. Now you will see generally in theoretical what we are going to explain in theoretical, light travels from rarer medium to denser medium means this is a denser medium. This is a theoretical explanation. Theoretical explanation. That is a practical explanation. Light travels from, this is a radar denser. This is a beam of light is traveling towards another medium. This is the actual direction of incident ray. But light travels from one medium to another means refractor is bending towards a normal, bending towards a normal line. This is we call refractor. Refractor. Now we will see what will happen in this situation, bending towards a normal. This is a theoretical. I'm showing this is a practical. I'm showing the practical. Our aim is also relation between angle of I, angle of R. Angle of I, angle of R. Now we will see what will happen in this situation. So now you will see what will happen in this situation? This is a light ray. I'm showing 10 degrees light ray. I'm taking light or light box. I'm taking the light box and keeping here. This is a light. This light this light is showing what showing this one. What showing? What showing? This is a light. We turn on the light means it passed one light ray. This light ray is passed along 10 degrees. 10 degrees. This is a beam of light. Beam of light is traveling towards the 10 degrees. Towards the 10 degrees. This is a beam of light. Beam of light is traveling towards the point of incident. Now this is a we call angle of incident ray. Incident ray. Now you will see this angle is, we call this is a normal line. This is a we call normal line. Here angle is what is the angle? This is angle is here 10 degrees. This point is 10 degrees. Now here angle is so much 10 degrees. This is angle of I is equal to 10 degrees. Angle of I is equal to 10 degrees. Now light travels from radar medium to delta. Do you know actual direction of incident ray is 10 degrees, but our ray is bending 6 degrees. Our ray is bending. This is the actual direction of ray. This is the actual direction of ray. Actual direction of ray along 10 degrees. Actual direction of ray. But ray does not travel in this direction. This refracted ray does not travel through the 10 degrees. It is bending. It's bending. Bending like this. So we call this is a refracted ray. This ray we call this is a refracted ray. But angle is here. Angle of R is equal to 6 degrees. 6 degrees. Angle of R is equal to 6 degrees. Angle of R is equal to 6 degrees. Now, so what we are seeing now in this situation. Now I'm going to calculate. This is a serial number. Angle of I incident ray. Angle of I, angle of R, sine of I, sine of R, sine of I by sine of R. We want to calculate. This is what we want to calculate. We want to calculate angle of I, angle of R, sine of I, sine of R, sine I by sine R, sine R. Now this is angle of I is equal to 10 degrees, angle of R is equal to 6 degrees, sine 10 degrees, sine 6 degrees, sine 10 by sine 6 is equal to this value. Now I want to that value. This is a serial number 1. This is a 1. This is a 1. This is a first one. Now you will observe in this situation. Generally, light travels from radar medium to denser. This is a beam of light is passes through 10 degrees and strikes at this point. Angle between N and I is equal to N and I is equal to 10 degrees. Now actual direction of incident ray is along. It passes through 10 degrees. Actual direction of incident ray is 10. But so this light, this is a refractor is bending towards a normal, below the 10. What is the angle cut exactly? above 6 degrees. Angle of R is equal to 60. But angle of I is equal to 10. Angle of I is equal to 10. Angle of R is equal to 6. Which one is greater? Angle of I is greater than 2 angle of R. Now, so our conclusion is refractor is less angle. Angle of incident is more angle. Now, our conclusion is light travels from radar medium to denser medium means refractor is bending towards a normal line. That is the relation between angle of I, angle of R. Angle of I, angle of I, angle of R. Now, second situation. Now I am seeing second situation. Situation number 2, I'm showing. Situation number 2, I'm showing. Like a second practical. Now you will see the second. We call this is a normal ray. So next one is like so next one more values I'm taking. One more values. Next light ray is passes 20. Light ray is passes 20. Light is on. Light is on. Light ray is on means this light ray is passes this direction. This is a light ray. This is a beam of light ray. Beam of light ray is traveling towards the point. This point. Beam of light. This is a beam of light. This is we call angle of light. Sorry, this is incident ray. We call incident ray. But angle between this is I. We call this is I. Angle between normal and I means this is angle of I. Angle of I is equal to how much? From here to here is 20 degrees. From here to here is 20 degrees. 20 degrees. Now, actual direction of incident ray is actual direction of incident. Actual direction of incident ray is this is the actual direction of incident. This is the actual direction of incident ray. This is the actual direction of incident ray. Now, so what will happen? Refractor ray passes. Refractor ray is passes. This is a refractor ray. This is a refractor ray is passes this direction. This is we call refractor. That is we call this line we call refraction. Here angle is here, angle of R is equal to so 15 degrees, exactly 15 degrees, exactly 15 degrees. Here angle of I is equal to 20 degrees. Light is passing through 20 degrees. This is a beam of light. Beam of light is traveling towards another medium. It is traveling to another medium. This is a refractor is passes through 15 degrees. Refractor is 15 degrees, and this is the angle of I is equal to 20. You will see second situation. Situation number 2. In this second situation, angle of I is 20. Angle of R is equal to 15 degrees. Sine of angle I means 20. Sine of R means what is angle? 15 degrees. 15 degrees. Sine 20 by sine 50 degrees. Sine 50 degrees is value. This is a constant value. That is a constant value. Now we will see angle of I is 20, angle of R is equal to 15 degrees. Angle of I 20, angle of R is equal to 50. Angle of I is greater than 2 angle of R. Angle of R. That means light travels from radar medium to denser, means this refractor is bending towards the normal, bending towards the normal. This dotted line indicates the direction of incident ray, actual direction of incident ray, but refractor is towards the normal, towards the normal. That is a relation between angle of I, angle of R. Now this is another relation. Angle I, angle of sine, angle of I, sine of angle of R. This is sine AB, sine R constant. I'm showing you this value. Next, situation number 3. Next, situation number 3. Next, situation number 3. Now, you will see situation number 2. So, what will happen? Next situation. Now you will see this is 20 degrees. Yes. Next, one more situation. Situation number 3. Situation number 3. Next, light ray is passes light ray. Next, light ray is passes 30 degrees. So light is placing here. Light is placing. This is light. So light is placing here, this direction. So light is on. Light is on. Light is on. Light is on. So what happened? Light is on means light ray traveling this direction. Light ray is traveling this direction. Light ray is traveling this direction. This is a light ray traveling this direction. That is a light ray travel this direction. This is a light. This is a 30 degrees. 30 degrees. This is a direction of light. Actual direction of incident ray is in 30 degrees. Actual direction of incident ray. Dotted line indicates actual direction of incident ray. Actual direction of incident. Light travels from radar medium to denser medium means what will happen? What will happen? This is a bending. Light travels from radar medium to denser medium. Refractory bending is towards the normal. Towards the. This is passing this direction. We call that is a So what we are calling this one? So we are calling this is a refractory. Angle of I is equal to what is the angle between here? This is a 5 degrees, 10 degrees, 15 degrees, 20 degrees. 20 degrees. Angle of R is equal to 20. Now we will see from here to here is angle. From here to here is angle. From here to here is angle of I is equal to 30 degrees. Angle of I is equal to 30 degrees. Now we will see. What will happen. Angle of I is equal to 30 degrees. Angle of R is equal to 20 degrees. Angle of R is equal to 20 degrees. Angle of R is equal to 20. Angle of I is equal to 30 degrees. Angle of I is equal to 30. Angle of R is equal to 20. But you will see Angle of phi is greater than 2. Angle of phi is greater than 2. Angle of r. Now, angle of phi is equal to 30. Angle of r is equal to 20 degrees. Angle of phi greater than 2. Angle of r. Angle of r. That is a relation between I and r. Next, refractor is this is the actual direction of incident ray. This is go, but the refractor is bending towards a normal. When it is bending, it's bending in this direction towards a normal line. This is a line. This is a line. We call this is a line. This line is we call normal line. Normal line. This is a normal line. This is a normal line. We are calling normal line. Normal line. That is a normal line. Okay. So now I am going to note down value is 30 degrees. Angle of phi is 30. Angle of r is 20 degrees. Sine 30 degrees. Sine 20 degrees. Sine 30 degrees by sine 20 degrees. Value is that value is I'm sure. Next, I'm going to another point. Now I'm taking to the 40 degrees. I'm taking to the 40 degrees. I'm taking to the 40. So light is on. Light is keep on 40 degrees. 40 degrees. Next, fourth situation. So light travels. This is light is keep here. Light on. Light is on. Light is on means the light ray passes. Light ray passes 40 degrees. Light ray passes 40 degrees. Light rays passes like this. Light rays passes like this. Now you are saying this is a we call angle of phi. Angle of phi is equal to this is incident ray. This is a beam of light. Beam of light is traveling towards the medium. So light ray is this is a beam of light is traveling towards another medium. This is we call angle between normal and I. This is the angle of I is equal to. So what is the angle? This is a 40 degrees. 40 degrees. Angle of I is equal to 40 degrees. Now light ray is travels from radar medium to denser medium. But actual direction of incident ray. Suppose for example there is no glass. There is no protector. So what will happen? This ray is traveling along in this direction. This is actual direction of incident ray. Actual direction of incident ray. But glass is present. The ray is refractor ray does not travels along that dotted lines. Refractor ray is does not travels that lines, but yeah, that is line is traveling in this direction. Exactly traveling this direction. Traveling that direction, and this is we call this is here angle of R. angle of R is equal to, here angle is how much? 0 degrees, 10, 20, 25, 25 degrees, 25 degrees. Angle of R is equal to 25, angle of R is equal to 25, angle of A is equal to 40 degrees, 40 degrees, 40 degrees. Now we'll see 40 degrees. Now, that is 40 degrees, 25 degrees, sine 40 degrees, sine 25 degrees, sine 40 by sine 25 degrees, 25 degrees. This is values I'm good. Now I'm going to calculate these values. Now I'm going to calculate these values. Suppose for example, sine 40 by, I'm calculating this one, sine 40 by sine 25. The value is 1.5. The value is 1.5. This is a 1.5. 1.5. So this is a value is also 1.5. So this is a value is this is value also 1.5. This is approximately 1.5. Approximately 1.5. You will see in all cases, you will see here 1.5, here 1.5. This is a 1.5, here 1.5, here 1.5. All values is a constant. All values is a constant. This is a constant. Now, theoretically, so refractive index of the glass is 3/2 or 1.5. 1.5. This is a value of refractive index. Refractive index of the glass is refractive index of the glass. Refractive index of the glass. Index of glass. Glass is 3/2 or 1.5. 1.5. I'm showing here. This is a activity, lab activity is over. Now conclusion. Now your conclusion. Now your conclusion. Now we will see lab activity 1. What we have to show here, a relation between angle of I, angle of R. Sin A by sin R is equal to constant. We have to show relation between angle of I, angle of R, and sin A by sin R is equal to constant. Here, sin A by sin R is equal to constant. Sin 10 degrees by sin 6 is equal to 1.5 approximately. Sin 20 by sin 15 is equal to 1.5. Sin 30 by sin 20 is equal to 1.5. Sin 40 by sin 25 is equal to 1.5. This is all are constant. 1.5, 1.5, 1.5, 1.5, all are constant. I'm showing this one. This is over. Now, relation between angle of I, angle of R. Do you know one thing? So what is one thing? Basic point, common basic point. Light travels from denser medium radar. This is a light ray, incident ray. This is the angle of I. This is actual direction of incident ray. This is a refractor ray. This is a normal line. This is angle of R. So angle of I greater than 2, angle of R. This is a condition. That only I'm showing. You see. So what will happen in this situation? Now what you are seeing here, light travels from rarer medium to denser medium. Refractor is bending towards a normal. This is theoretical. I'm showing the practical here. In the first case, you see all cases. In the first case, angle of I is equal to 10 degrees. 10 degrees angle of I, but the angle of R is 60 degrees. You see the condition, condition, you see angle of phi greater than angle of r. Light travels from radar medium to denser medium means angle of phi greater than angle of r. You see the first situation, angle of phi greater than to angle of r. In the second situation, incident ray is 20 degrees, refractor is 50, angle of phi greater than angle of r. The third situation, incident ray is 30, refractor is 20, angle of I greater than angle of RS. The fourth situation, angle of I greater than angle of RS. Angle of incident ray is 40, angle of R is 25, angle of I greater than angle of RS. So you see that in the all situation verified. Now light travels from radar medium to denser medium. Radar medium to denser medium. This is a radar medium. This is a denser medium. Denser medium. Denser medium. This is a radar medium. This is a denser medium. In the first case, you see the in the first case, angle of I, light ray is beam of light. Beam of light is passing through the 10 degrees. Beam of light is beam of light. Beam of light is traveling towards the normal, towards beam of light is traveling towards another medium that is called as incident ray. I and N is angle is 10 degrees. First case is 10 degrees. This is a first case. Beam of light is traveling towards another medium. I and N is angle is 10 degrees. Next, light travels from radar medium to denser medium. Actually, our angle of R is equal to 60 degrees. 6 degrees. Next, the second situation, light ray is passing 20 degrees and refractor ray is 15 degrees. And third situation, light ray is passing through 30 degrees, angle of I is equal to 30 degrees, angle of R is equal to 20 degrees. Next, fourth situation, angle of I is equal to 40 degrees, angle of R is equal to 25 degrees. 25 degrees. This is a relation between the angle of I and the angle of R. Angle of I into angle of R. This is a situation. Angle of I, angle of R in this situation. This is a lab activity. One explanation. In this concept, what I'm explaining, what I explained in this concept means, actually the basic thing is light travels from radar medium to denser medium. Light travels from radar medium to denser medium. This is angle of I, this is angle of R. This is a relation between angle of I, angle of R. Angle of I greater than to angle of R. This is a relation between angle of R, angle of I. Angle of I, angle of R. That is a relation between the angle of I, angle of R. Next, another relation between another one. This is a sin A by sin R is equal to constant. This is a sin A by sin R is equal to constant. I'm showing you answer. First situation, I'm getting angle of I 10, angle of R 6. Second situation, third situation, fourth situation. Sin 10 degrees, sin 6 degrees. Sin A by sin R is equal to 1.5. 20, 15, sin 20, sin 15, sin 20 by 15 is equal to 1.5. 30 and 20, sin 30, sin 20, sin 30 by 20 is equal to 1.5. 40, 25, sin 40, 25 is equal to sin 40, 25 is equal to 1.5. And glass, refractive index of the glass is equal to 3 by 2, 1.5. This is a projector is made up of the glass. The value is refractive index is 1.5. But so we did the practical way, so we got 1.5. Both are equal. That only I'm showing this in this answer. This is a lab activity 1. Now, in your examination, you don't want to write this explanation. You don't want to write this explanation. In your book, given neatly. So these values, you don't mention your examination, final exams. You don't take this all values. Don't want to need. So these values, I'm going to explain. This is a practical way. Okay. In the exam, so there are asking to this question. Explain the lab activity 1 means. So we want there is a relation between angle of I, angle of R, and sin A by sin R is equal to constant means. So first, what we have to write means first. In exam point of view, how can you write this explanation? I'm going to explain. So first of all, you start like this. So first up, you should put the. So you put the A. So A put here. A means what we have to do. Relation between angle of phi, angle of r, and angle of I by angle of r is full constant. I'm showing. Next procedure. Next require the material. Material required. Material. What type of material you want? You want protector. You want one board, and we need one board. Eh? Next one board, and you need one sheet and a white sheet, and you need clamps, the clamps, and we need pencil, protector, and a scale, eraser, and one more thing, pins. We need this all things. This is a material required. Material required. Next to procedure. Next is procedure. What we have to do, that only I'm going to explain. Procedure means first of all, we arrange the table. We arrange the table. Next, I'm taking the white chart. White chart keeps on the table, and this white paper does not slide. Does not slide means we take the clamps. Clamps attach the paper, and clamp attaches the paper and board in all four corners. Now paper is tight. Now again you have to draw the border lines with the help of the pen and pencil and scale. Now, so next in the paper can be divided into two parts. I mean, you draw the two lines. So we draw the two lines. One line is horizontal to the paper, another line is vertical to the paper. Vertical to the paper. Now this get divided. Now next, this is you mark like this. This is 0 degrees, 10, 20, 30, 40, 50, 60, 70, 80, 90. And this is 0 degrees, 10, 20, 30, 40, 50, 60, 70, 80, 90. Like this you can draw. So we have to draw these all points on the chart. Next, this part is filled with air. This part is filled with glass. Protector is made up of the glass. The protector keeps this is origin point. The protector 0 point and the center of our point should be coincide. The protector keeps along the lines. This is you take this is line C. For example, this is a M line. This is a MM lines. This is a M dash. Or now you can take whatever. This is a MN line. This is a MN line. This is what we call MN line. This is a PQ line. PQ line. You can mention PQ line. Now protector. Protector should protector having the one line, and already the paper having the some lines, and we coincide the protector line and the paper lines. Both are coincide. The protector arrange the both lines should coincide. Now you will see the figure is ready. The diagram is ready. Next one, what we have to do? Light ray is passing 10 degrees. After what will happen? The light ray is refractor is bending towards bending rays passes 6 degrees. Next second, light ray is passing 20 degrees, and refractor is bending. Refractor is passing through 50 degrees. Next third situation, light ray is passing 30 degrees, and refractor is passing 20 degrees. Next, light ray is passing through 40 degrees. I mean, angle of incident is 40. Refractor is 25 degrees. We are getting all values. You don't want to explain these values. You don't want to explain. You don't want to write this all calculation. Just you have to draw the tabular form. What you have to draw the tabular form means angle of I, angle of R, sin of I, sin of R, sin of I by sin of R is equal constant. You have to draw this table form. Don't fill these values. This tabular form does not fill these values. So we don't want to require. Now this is a relation. I'm showing this is constant. I'm showing this is a relation. This is always greater than to this one. Refractor is bending towards a normal. This is you have to write this manner in your exam point of view. You will get the full marks. Okay. Now this is your concept. So finally, what is the conclusion? This is a theoretical explanation. This is a practical explanation. You are seeing this is angle of I is greater than angle of R. all situation, angle of I or greater than angle of R, all situations. Situation number one, you see this is situation greater than the all situation. All situations are verified. All situations are verified. In this constant, all situations, situation number one, 1, 2, 3, 4, all situations we are getting 1.5 constant value. This is a concept. This is a what concept. Now, this is a next. I'm going to explain lab activity 2. Lab activity 2. Next lab activity 2. Lab activity 2. Glass lab. Lab activity. Lab activity 2 more. Now you will see. Lab activity 2. Okay. Time is over. Tomorrow I will explain lab activity 2. Lab activity 2. So what is a lab activity 2 means? I'm going to show the lateral shift and glass lab. Glass lab. Glass lab. I'm showing the lateral shift. Lateral shift. That is a very important and very simple simple lab activity. Simple lab activity. I'm going to explain this lab activities tomorrow and before this time. Before this time. Now your today class is over. Today class is over. Okay. You have any doubts, means contact with me.